Lab 3, Magnetic Field of a Bar Magnet by Anna Catherine Brewer. Introduction and Models. The purpose of this lab is to measure and record the magnetic field of a bar magnet and compare that result to what the Boyd-Shivart law would have predicted. The main result for this lab will hopefully be that the Boyd-Shivart law is very accurate for calculating magnetic fields. The main physics ideas I utilized for this lab were the Boyd-Shivart law and distance dependence, which can be shown in the two pictures below. I chose to use the Boyd-Shivart law because it determines the magnetic field. For distance dependence, K is a combination of constants and parameters such as magnetic moment, which are constant. After measuring B bar at different distances from the bar magnet, I will solve for N. Experiment. The system is the bar magnet and the surroundings are everything else. For the experiment, I first downloaded the magnetometer app to record the net magnetic field. Then I placed a bar magnet oriented east to west at one end of a meter stick, while compensating for magnetic north. Next, I found the distance from the sensor required by the magnet to generate certain values of the magnitude of the magnetic field. I did this on axis perpendicular to the axis and 45 degrees from the axis. For initial conditions, I treated the bar magnet as it was the origin and found that the magnitude of my measured magnetic moment was 2.66. This is the graph of all of my final results. Coding calculations and observations. So, as the magnetometer moved closer to the magnet, the measured X component of the magnetic field increased. When the magnetometer was farther away from the magnet, it measured a near zero magnetic field in the horizontal direction. For my calculations using the Boyd-Shivart law, I found that the magnetic moment was approximately 2.66. The y-intercept of the results on my graph was negative 14.446. Using the distance dependence equation, I found that my k value was 5.21 times 10 to the negative 7, and I found that my n value was negative 2.8823, which is the slope value of the results graph. Code. This lab was pretty straightforward. After calculating the values on the previous slide, I inputted them and other values from my experiment into the GlowScript starter code that was provided to us. This is a screenshot of my code. This is another screenshot of my code. And this is the final part of my code. This is the computational model that my code generated, with the white object in the center being the bar magnet. Discussion. Although there were some slight deviations, the result of this lab was similar to what the Boyd-Shivart law predicted. A possible source of error for this lab was a deviation in the magnet to sensor distance that resulted in a magnetic field X component of 20 microteslas. I feel like this distance could differ greatly depending on people's phone qualities. Concluding thoughts. What if you hadn't oriented your experiment to compensate for magnetic north and had instead laid your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? Well, Earth's magnetic field would have then impacted the magnetic field that I measured. This would make the results less accurate. What if I were to stick two identical magnets together, end to end, and run the experiment again? How would you expect your measurements to differ? Well, the magnitude of the field would be stronger, and the direction would not change. This is because the two magnets would be end to end and therefore working with each other. Thanks for listening, and here's the link to my GlowScript code.